Since the 1800s, we have been burning fossil fuels to power vehicles, heat our buildings, and manufacture goods. This graphic by NASA shows a general trend of increasing temperatures since the late 1800s. With temperatures increasing, Arctic sea ice has been decreasing as well. The 1990s marked a period of intensified warming across the globe, and this trend has not stopped. In fact, the rate of global warming doubled in the last 50 years. Surprisingly, while 97% of scientists believe in climate change, only 50% of the public does. This short film will present lines of evidence that climate change is happening. Climate change means more than just warming temperatures. Scientists are predicting changes in global storm patterns as well. That is what this film will focus on.
Climatology is the study of trends in weather over a period of time. The topic of climate change refers to the change in weather trends from what is the norm that is persistent for a stretched period of time, like decades. This would not include a sudden change in weather from one day to another. Climate is controlled by the Earth's energy budget. The balance is fragile and any change can modify the world's climate. The imbalance in the energy system can be caused by internal processes or external forcing. Internal forcing are the most natural processes on Earth, like the formation of reflective surfaces like ice sheets or interaction between different Earth components. For example, atmosphere-ocean interactions can create events like El Niño Southern Oscillation, which causes local climate change every 7 years. External forcing involves outside events like volcanism or solar irradiance, which causes a change in the amount of incoming energy. The more influential external forcing on climate change is anthropogenic forcing, which is caused by human activities. The main human activities are the burning of fossil fuels, which release additional carbon dioxide into the atmosphere, which would normally be preserved in carbon sinks. Changing of land use through agriculture and deforestation also has a large impact. Human activities are responsible for a projected 35 billion metric tons or gigatons of CO2 emissions in 2010, compared to the tiny 0.13 to 0.44 gigatons released by volcanoes each year. Humans have produced a significantly larger amount of CO2 emissions than naturally occurring events, creating levels higher than any time during the past 650,000 years, and probably much longer. CO2 in the atmosphere acts as a greenhouse gas which radiates energy that is trying to reflect back out into space towards the Earth's surface. The recent climate trends have a wide impact on the Earth. It causes sea level changes, extremes in weather, increased storm frequency, and impacts on human health. The record-breaking number of named storms in 2005, the record number of hurricanes, the unprecedented 4 Category 5 storms, along with record damage is part of the upward trend towards more active hurricane season in the North Atlantic since 1995. The more noticeable effect of climate change are the ones affecting people. We are experiencing more heat waves, droughts, expensive storm damage, and spread of diseases. This all contributes to the easy formation of storms. The sun provides energy to evaporate the already warm ocean, producing a moist atmosphere. As the warm air rises, it cools and forms clouds. The clouds grow and begin to rotate as they rise. Rotation is due to the rotation of the Earth, causing storms to rotate counterclockwise in the northern hemisphere and clockwise in the south. This is called the Coriolis effect. The system rotates faster, causing an eye to form in the middle.
Let's review the global water cycle. Precipitation falls on the surface of the Earth, where it percolates into the ground or flows off as runoff, trying to reach the ocean. Water evaporates back into the atmosphere to form condensation. This condensation will eventually fall as precipitation to continue the cycle. Warm, less dense water entering the ocean, represented in this experiment by the red coloring, will remain close to the surface. Denser, cold blue water entering the ocean will sink. According to the Intergovernmental Panel on Climate Change, a warmer ocean will contribute to sea level rise due to thermal expansion of water molecules. Under climate change, sea surface temperatures have risen 0.5 degrees Celsius since the last 50 years. As a result, more evaporation is occurring from the oceans, creating more condensation and fueling the formation of larger storms. In fact, atmospheric moisture has increased 4% near the oceans over the past 50 years. So why does this matter? Increased atmospheric water vapor increases instabilities and intensifies storms. Scientists believe storms will increase by 10% for every 3.5 degree Fahrenheit increase we experience. An increase in storm intensity is very regionalized, however, directly related to atmospheric water vapor concentrations. For instance, high surface temperatures of the Indian Ocean cause extreme precipitation events in South Asia and Australia and extreme drought in Russia. In general, hurricane intensity has increased over the past 40 years, though still within natural variability. Additionally, sea level has risen approximately 3 to 4 millimeters per year along the East Coast due to melting of continental glaciers, as depicted here, and thermal expansion of seawater. What is expected to happen this century? The IPCC climate models disagree on severity and frequency of future storms. However, a poleward shift in subtropical storms is predicted. Several studies indicate an increase in storm intensity and frequency in the North Pacific and the European North Atlantic, but a global pattern of storm intensities remains constant. Additionally, Asia is also predicted to have an increase in storms. Meanwhile, the Gulf of Mexico, southwestern North Pacific, North Africa, and the high latitudes are predicted to experience a decrease in frequency of storms. Importantly, these predictions are based on many models with differing uncertainties.
Hurricane Sandy was a Category 5.8 hurricane that struck the East Coast in late 2012. In the United States alone, 125 people lost their lives. Another 71 were killed in the Caribbean and 54 in Haiti. It cost $62 billion in damages in the United States, most of it in New York City. Thousands of people lost their homes, jobs, and businesses. Even parts of Atlantic City and New York's Coney Island were destroyed. 2005's Hurricane Katrina is another storm that will go down in history. Katrina struck the Gulf Coast, killing 1,836 people. Another 400,000 people lost their jobs. Damages from Katrina are estimated at $110 billion, making it the most expensive storm in our nation's history. Over 275,000 homes were lost, along with businesses and environmental damages. If the economic damages weren't severe enough, people unknowingly sent $1.4 billion in aid to people unaffected by the storm. These people used the money for personal use and funded vacations and season tickets to football games. The most deadly storm to strike the East Coast in over 200 years was Hurricane Mitch. Mitch killed over 11,000 people in Central America in 1998. Thousands of other people went missing, and over 3 million people lost their homes in an already poverty-stricken area. Damages in Central America reached $5 billion, and since this area already had a lot of economic growing to do, this storm was a devastating setback. Since people are becoming more aware of climate change, they are ready to jump to conclusions about why these major storms have been happening. Even though climate change did not cause Sandy, one poll found that 69% of voters thought Sandy, Irene, and Hurricane Lee were all a result of climate change, where only 24% thought these were isolated events. Even though recent storms were not caused directly by climate change, the U.S. government is taking steps to combat further changes. The Environmental Protection Agency is built around protecting the environment and educating people about the truth and myths of climate change. The EPA is doing a number of things to collect valuable data that can be used to teach people about what they can do to prevent further climate change. One of their major achievements is collecting emissions data to help businesses and agencies track their emissions and identify and solve any areas that may be causing unhealthy amounts of greenhouse gases to be released into the atmosphere. Every year, more and more people are finding ways to reduce their carbon footprint. Composting and using bicycles in public transportation are some of the many ways the public is taking action.